This is Ham College, episode 111 for March 29th, 2024. Ham College is brought to you by Icom. Put a spring in your step with Icom. Get outside this spring and work out the kinks in your station. Icom has the radio for you. Good evening. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And it's going to be an interesting episode tonight. We're covering a different topic than, well, it's a different one every month, but it's a little more different this month.
It's an unusual thing for me to, something I don't use.
So, what did we talk about last month?
Well, let me think back about that. I think we must have talked about transmission lines, characteristics of open and shorted feed lines, maybe some coax versus open wire, velocity factors, electrical lengths, and it seemed like there might have been a little coax cable dielectric stuff thrown in there for good measure.
I think you're probably right.
Just off the top of my head.
Yeah. This month, we're going to talk about the Smith chart. Now, here, that's a pretty tough subject.
Tell me about it.
And, you know, the cheap old man keeps us on a budget. So all I've got here tonight is a Jones chart. So we'll have to draw our own circles on it.
Okay.
Actually, I do have one. That is it.
Spirograph thing from when I was a kid.
It kind of is. We're going to go through all the questions here. After it's all done with, I've got a video. I went back to my Smoke and Solder archives and dug out a video that I did on the Smith charts back in
1900
Well, no, it wasn't 1900, but I think probably 2016, sometime around then. But it's a little example on one thing you can do with it, because you can do a lot of different things with these. Dean?
Go ahead and just have the disclaimer now that if you're sensitive to buzzing, loud buzzing sounds, you may want to go ahead and put some hearing protection or turn your volume down.
Okay. Which of the following can be calculated using a Smith chart? A, impedance along a transmission line.
B, radiation resistance.
C, antenna radiation pattern.
Or D, radio propagation. Well, I can tell you right now it's not going to be D. It's not going to be C either for a Smith chart. At least I don't think. Radiation resistance. I'm going with A on this one. Impedance along transmission lines. That's the one that makes sense.
Okay. We'll wait a minute.
The others don't.
To let a few more answers come in the chat room here. Looks like those brave enough to answer are saying A.
This may be the only one I get tonight, assuming this one's right.
Nah. I mean, if you got this one, you'll get the rest of them.
You think? We'll see.
Maybe.
We'll see.
All right. Everybody so far said A. There you go.
A. What type of coordinate system is used in the Smith chart? A, voltage circles and current arcs.
B, resistance circles and reactance arcs.
C, voltage lines and current cords.
Or D, resistance lines and reactance cords. What type of coordinate system is used in a Smith chart? Well, it's not an instrument that you play music on, so
it doesn't have any chords.
I don't think it has any chords spelled like that anyway. So I'm going to knock out C and D. So voltage circles and current arcs, nah. Resistance circles and reactance arcs, B. That's going to be my answer. Everyone in the chat room is getting it. You know, there's a lot of smart Smith chart people here tonight.
Yep.
We'll see if it holds out.
All right, I'll give you that.
Okay.
There you go.
Off to a good start here. Which of the following is often determined using a Smith chart? A. Beam headings and radiation patterns.
B. Satellite azimuth and elevation bearings.
C. Impedance and SWR values in transmission lines.
Or D. Trigonometric functions. I hope that's right.
I can't even say that.
Trigonometric functions. That's how I'm saying it.
Okay.
That's my answer. I'm sticking to it. That's not my answer. It's not D because I can't even say it.
Yeah. I'm not sure there is such a thing as D.
No. So, C, impedance and SWR values. That sounds plausible. B, satellite azimuth. No. A, beam headings. Nope. The only logical answer up there is C. It's got to be C.
All of us are agreeing with you. It is C. These are not so hard after all.
So far.
Yeah.
What are the two families of circles and arcs that make up a Smith chart? A, resistance and voltage.
B, reactance and voltage.
C, resistance and reactance.
D, voltage and impedance. What are the two families of circles and arcs that make up a Smith chart? Let's just look at the Smith chart again. Circles and arcs.
And plenty of them.
It just amazes me somebody actually figured that out and then was able to draw it. That's pretty intense.
It is.
Drawing there. What are the two families of circles and arcs?
To visualize it like that is.
Resistance and voltage. No, it's not voltage. Reactance and voltage. There again, not voltage. D, voltage and impedance. Not voltage. C, resistance and reactance.
So you're saying it's not voltage.
I'm saying it's not voltage.
That's all I got from that.
C.
Yeah.
Chat room saying C.
Yeah, that's right. We actually covered this on an earlier question too.
Yep.
Just worded differently.
Resistance and reactance. Which of the following is a common use for a Smith chart? A, determine the length and position of an impedance matching stub.
B, determine the impedance of a transmission line given the physical dimensions.
C, determine the gain of an antenna given the physical and electrical parameters.
Or D, determine the loss of 100 feet of transmission line given the velocity factor and conductor materials. I don't think that calculates losses per 100 feet. Determine the gain of an antenna. It's not. No, I don't think it's a gain calculation either. Determine the impedance of a transmission line given the physical dimensions. Determine the length and position. B seems somewhat plausible, but A seems like the more likely answer. I've never used a Smith chart ever, so but I know it's on my Nano VNA.
Yeah.
And so it's a function of one of those things for that tool. I think it's probably more likely A, that you can determine the length and position of a stub, but I'm not sure.
So is that your answer?
Yeah, A.
That's what the chat room's saying.
Room's saying too. So.
Yep.
Oh, that was lucky.
Joe said, when asked why he invented the chart, Smith explained, from the time I could operate a slide rule, I've been interested in graphical representations of mathematical relationships. And I would say, yeah, that kind of...
He mastered that.
Not that exactly, but when I was thinking about the Smith chart this week, I thought about my slide rule too, and about how I haven't used it in a lot of years. And anytime I pull it out and look at it, pretty much have no idea what to do with it.
Put it back in the drawer it was in?
Yeah. I can, if I fool with it long enough, I can figure out how to multiply again through trial and error, just until something works. But other than that, the Smith chart is kind of like, used like a slide rule. You figure out problems with it.
Yeah.
You work out calculations. So that's cool. He said in 1969 he published the book Electronics Applications of the Smith Chart and Waveguide Circuit and Component Analysis, a comprehensive work on the subject. He retired from Bell Labs in 1970. Okay, today, I don't know, there's still people using a Smith chart. But just in my mind, there's probably computer programs that do most of this.
Yeah.
So,
like I said, it's built into your NanoVNA too.
It's built into
Smith charts are in there.
A lot of the stuff in antenna analyzers.
I actually looked at it when I first got that, but I looked at it and I kind of saw what it was doing, but that's about as far as I went. I know I didn't like it too much, and I just moved on.
Yeah,
but probably ought to revisit it. Might make an interesting segment. Somebody might learn from it. I might learn something from it. Actually, I'm sure I will.
Yeah, it's in one of my antenna analyzers, my Rig Expert. But I looked at it and I couldn't really figure out what good it was doing me to see it.
On the Smith chart shown in figure E9-3, what is the name for the large outer circle on which the reactance arc terminate? A, prime axis.
B, reactance axis.
C, impedance axis.
Or D, polar axis. On the Smith chart shown in figure E9-3, what's the name of the large outer circle on which the reactance arcs terminate? The large outer circle, what we plot on there is reactance. What were my choices? Prime axis? Nah. Reactance axis. I think that is it. Impedance axis or D, polar axis. I'm going to say it's B, reactance axis.
Well, it's mostly reactance and resistance, right? So
yeah, we didn't get many answers on that one. And they're mixed. So
it's a tough question when they don't start just popping in on the chat room.
Yeah. Yeah.
I would have guessed B.
It's leaning toward B.
Because earlier we did say it's reactance and resistance.
The ham math guy said it's B. Now, if he thinks it's B,
it's got to be B.
It's got to be B. It is B.
A ham math guy should know.
Yep.
He was right on the money.
Well, I got another one.
Okay.
And this one, this will be your opportunity.
To redeem myself?
To redeem yourself. On the Smith chart shown in figure E9-3, what is the only straight line shown? A, the reactance axis.
Ooh. B, the current axis.
C, the voltage axis.
Or D, the resistance axis.
The reactance axis, the current axis, the voltage axis, or the resistance axis.
Well, since the other one was reactance, I'm going to go with resistance. I don't know which option that was because I can't see the letters on the...
resistance is D.
Well, then I'm going with D.
There you go.
But if I hadn't had that other question first, I would have been either reactance or resistance. I wouldn't have known.
Well, you'd have had a 50-50 chance.
Yeah. Well, it's better than 25% chance that I had before.
It is. Well, what do you say we take a break right here? Because the questions are going to get just a little bit tougher.
Say it isn't so.
It is so.
Put a spring in your step with Icom. Get outside this spring and work out the kinks in your station. Fixing ice-damaged HF antennas, preparing for an upcoming VHF contest, or portable operations, Icom has the radio for you. Upgrade your station with one of Icom's fabulous HF radios. With the IC7610, faint signals are no longer challenging for DXers and contesters. The high-performance RMDR can pick out the faintest of signals even in the presence of stronger adjacent signals. This is the SDR every ham wants. With Icom's IC905, VHF contesting is a breeze. This all-mode rig covers 5 bands with one radio: 2 meters, 70 centimeters, 1.2 gigahertz, 2.4 gigahertz, 5.6 gigahertz bands, and with the optional CX10G transverter, 10 gigahertz. Large color touchscreen, easy D-Star settings, and a separate controller and RF module configuration to reduce signal loss. Explore the world of microwave with the IC905. The IC705 and IC7300 are the perfect go-to rigs for outdoor hams who love POTA and SOTA activations. Both radios feature a large touchscreen with real-time spectrum scope and waterfall for intuitive function and setting operations. The IC705 provides base station features and performance in the palm of your hand from HF to 50, 144, and 440 MHz. The IC7300 is an industry first, using RF direct sampling in an entry-level HF radio. If you're getting a head start on hurricane season, Icom's IC7100, ID5100, ID50, or ID52 are the perfect traveling companions and should be on your go-kit list. From high-powered base stations to compact and travel-friendly handhelds, Icom radios offer in-demand features and functions to keep you active on all bands, inside your shack or out in the field. For more information about Icom's amateur radios, visit icomamerica.com/amateur today. You could win an Icom Ham Crew t-shirt courtesy of Ham College and Icom. It's pretty easy to do. All you got to do is enter to win. And to enter, just send us an email to hamcollege@AmateurLogic.TV. You can put a message in there if you'd like to. You don't have to, but you do have to have a name.
Do you need
and
a call
an email
sign?
address. You don't need a call sign.
Cool.
You know, you don't even need a body in your message. But, you know.
But you need one to wear the shirt.
You need one to wear the shirt. We've got a winner right here. We did a drawing before the show tonight.
Dean Berglund. Hi, guys. Love watching your shows. I'd love to enter your drawing. My info is Dean Berglund, KC9REN. Congratulations, Dean. You won.
Yep.
You're the winner this month. And you'll hear from Jesse sometime soon about your stuff to get your size information and everything.
Yep.
So
Cool.
what happens to the people that didn't win? The queue gets cleared out, right? So
Right after we drew this, I emptied it. It is empty right now.
So go ahead and get your entries in for next month's drawing.
Mm-hmm.
Go ahead and send them to the address that's on your screen right now, hamcollege@AmateurLogic.TV, so you can win next time, hopefully. What is the process of normalization with regard to a Smith chart? A, reassigning resistance values with regard to the reactance axis.
B, reassigning reactance values with regard to resistance axis.
Reassigning impedance values with regard to the prime center.
Or D, reassigning prime center with regard to the reactance axis.
Yeah, I'm glad you got this one.
What is the process of normalization with regard to a Smith chart? A, reassigning resistance values with regard to the reactance axis. That would make no sense. That is not A. B, reassigning reactance values with regard to the resistance axis. That wouldn't either. C, reassigning impedance values with regard to the prime center. Or D, reassigning prime center with regard to the reactance axis. I'm going to say it is C, reassigning impedance values with regard to the prime center.
Why would that be the answer?
Well, let's see if I'm right, and then we'll talk about it. Chat room.
Yeah, it's mostly C's. There's a D in there too.
Yeah. Why would you do that?
Why is that the answer?
Well,
Impedance values.
let me pull it up right here. So what we're going to plot on a Smith chart is typically resistance and reactance.
Mm-hmm.
50 ohms is a real popular impedance for a transmission line.
Yeah.
So is, 300 ohms, 75 ohms, 450. I don't see those numbers on this chart anywhere. And we're talking about the prime center. That's going to be in the center of the chart. Right there, that red dot.
Okay.
That is 1.0. Now, you could use the Smith chart with transmission lines with different characteristic impedance. Like you could use it with 50 ohm line. You could use it with 75, 450 ohms, whatever you want. And you normalize it so that whatever your characteristic impedance is going to end up right here on 1.0. Let's think about it this way. Say we know the actual impedance, or we measure the impedance of our line. Let's say it's 48 ohms.
Mm-hmm.
And we're using RG8, which has a characteristic impedance of 50 ohms.
Mm-hmm.
The way we've normalized that number is to take the actual impedance, 48, and divide it by the characteristic impedance, 50, and that would give us the normalized impedance. It was 48 impedance, and I said we divided it by
50.
50, the characteristic impedance, 0.96. There's one, there's 0.9, that would be 0.95, so it would be right around here. So that would represent 48 ohms, because one would be 50 ohms in this case. If it was 300 ohm line, that one would represent 300 ohm. And
Okay.
we'd have to take whatever impedance we want and divide it by 300.
I got you.
So that's all you're doing is scaling that so that one represents your characteristic impedance. And you just scale the whatever impedance you're working with.
That makes sense.
Yep.
It's interesting.
We're going to actually do all of that stuff here after we go through the rest of the questions. We'll look at a little video where I did it a number of years back. What third family of circles is often added to a Smith chart during the process of solving problems? A, standing wave ratio circles.
B, antenna length circles.
C, coaxial length circles.
Or D, radiation pattern circles. Well, I don't think it's going to be, it's not D, radiation patterns. Coaxial length circles? I don't think it's going to be D, C either. B, antenna length. It's got to be A, standing wave ratio circles, because that's kind of what we're interested in mostly with this stuff.
There's more than one type of problem you can solve with the Smith chart.
Yeah. Well, I might be wrong, but I don't think it's B, C, or D problems.
I don't think it is either. I think you're right. Chat rooms, they're all saying A. And it is. No buzzer yet.
Strange.
How'd that happen? Yeah.
I don't know. What do the arcs on a Smith chart represent? A, frequency.
B, SWR.
C, points with constant resistance.
D, points with constant reactance. Wow. What do the arcs on a Smith chart represent? Well, it's not frequency. Look at this. What are arcs? To me, there's a lot of arcs on there.
I'm assuming they're those to the
Right
starts
here?
there and goes around up to the right top. That's an arc.
Okay. Points of constant reactance. I almost said resistance, but
Well,
I'm
that's
saying
pretty much what
reactance.
everybody else in there said too. So
Okay.
must be something to it. I probably would have guessed D, maybe. I'm not really sure.
Yeah.
It wasn't up to me, so I didn't think that far.
How are the wavelength scales on a Smith chart calibrated? A, in fractions of transmission line electrical frequency.
B, in fractions of transmission line electrical wavelength.
C, in fractions of antenna electrical wavelength.
Or D, in fractions of antenna electrical frequency. I'm going with B. This is a pure guess.
Well, everybody in the chat room's got the same guess as you. There you go.
Was that the last question?
That is the last question. There were only 11 in this section.
Wow. I can't believe there wasn't a buzzer because I knew for sure there was going to be at least one.
Yeah. There wasn't. I was thinking there was a good chance there would be one too. And I almost thought I caused it to function a moment ago. But it didn't. So here's a video I did. Like I say, I think it was 2016. A few weeks ago, we looked at Smith charts, and I told you we would revisit the subject and actually do something useful with it. Well, that's what we're going to do this week. We're going to show you how to plot VSWR on a Smith chart. We're going to start with some values here that I got from measuring two 50 ohm terminators with an antenna analyzer. I measured a resistance of 27.3 ohms and a reactance of a positive 9.51. We have to normalize these numbers for 50 ohm characteristic impedance. So we're going to say 27.3 divided by 50. That gives us 0.546. And for the reactance, 9.51 divided by 50 equals a positive 0.1902. Now let's revisit how we plot these numbers on the Smith chart first. The horizontal line going through the middle of the chart is where we mark our resistance. The inner circle here with numbers is where we mark reactance. If it's a positive reactance, then we use the numbers above the center line. If it's a negative reactance, we use the numbers below. So we'll mark our resistance first. That should be normalized to 0.546. If we go along the center line here, there's 0.6, there's 0.5. 0.546 would be about right here. Since this line would be 0.55, we'll just mark right above it. I'm going to zoom in a little bit so you can get a better look here. Not a very flat line there, but this is approximately where we want to be, just above the 0.55 line there. Now let's mark our reactance. It normalizes to be a positive 0.1902. So we go in the positive direction here. There's 0.2. We need 0.19. So it'll be just under that line. And the point where the two lines cross here, which would be approximately that spot, that's going to be a resistance of 27.3 and a reactance of 9.51. Now let's determine the VSWR. We'll need a compass, and we'll place the center of it right here on the 1.0 mark on the resistance line. And we'll place the marker where our two lines intersected here. Now we draw a circle. And we don't have to make the whole circle. What we really need is to know where it's going to cross the resistance line here. There's 1.6, 1.8. This would be 1.9. We're just over that. About 1.92, 1.93. And when I took the measurements using the antenna analyzer, it told me I had a VSWR of 1.92. So there, very close to what the antenna analyzer said. So there you go, how to determine SWR with the Smith chart. Apparently last time I showed you a Smith chart, we talked about how you plot the resistance and reactance on it. I got it wrong, and nobody really mentioned that to me. Probably because you couldn't see very good on the camera. Let's zoom in a little bit here. We were trying to plot 0.546. Well, when I made my marks here, I went in the wrong direction.
Oh!
There's 0.5 right there. I should have come this direction. Instead, I went below 0.5. How did I notice that I made a mistake several weeks ago? When I went to plot out the SWR curve, line my pencil up, when I went to make the circle, I noticed the SWR was a lot higher than it should have been. So there you go. Pay attention which direction the numbers on the chart go.
It is interesting. It's a really neat chart. Like today, in today's time, I'm not sure why you would use it. Other than just
Yeah, I mean, it was like a slide rule back in the day.
Yeah.
For the transmission line type of problems, but today, you know, probably computer programs, antenna analyzers. There's actually formulas you could use. If you knew the resistance and the reactance, with those two numbers, you can calculate out the VSWR.
Well, how do you get those?
I don't remember the formula right off the top of my head, but it's a real simple formula. With a calculator. I think square roots are involved in it. But anyway, before you had a calculator and you're going to have to pull out your slide rule, this was a quick way to do it. Now, that is probably about the simplest thing you could do on a Smith chart.
Yeah.
The rest of it, well, this is as far as I ever got with it. I didn't take it any farther than that.
Yeah, that was probably plenty far enough.
It was. There's people over here in the chat room, particularly Tom, that knows a lot about Smith charts. So if you have questions about Smith charts, you can address them to Tom. I'm not going to give out his call sign because he might not want to do tech support on this, but there's a lot you can do with it, and it is good for visualizing things.
It's neat stuff.
Yeah.
I'm probably going to have to look into it a little bit more now just because it kind of sparked my interest.
Yeah. Yeah. See what you could do with it.
Yeah.
I'm going to look at my antenna analyzer over there and see now if I can, I'm going to pull out that same pair of terminators that I used to get 27.5 ohms with and see what kind of Smith chart it draws on there.
Yeah.
Be interesting to see. But anyway, there you go, Smith charts. Ham Math Guy said it is possible to find Smith charts with 50 ohm prime center. That way there's no need to normalize. I have not seen one. There's also an X and a Y version of a Smith chart. I didn't really look to see what the difference was, but I'm thinking this one is going to be an X version, and the one that we looked at from the question pool that didn't have many circles on it earlier, I'm thinking it was a Y version because the resistance was going up and down, and this one it's going horizontal.
Yeah, good chance.
Any parting thoughts for tonight? Any words of wisdom?
No, if you can't afford a Smith chart, get a Jones chart.
There you go.
Other than that, have a happy Easter.
Yep.
And see you in a couple weeks for Amateur Logic.
Yeah, we hadn't really figured out what date that is, have we? It's either going to be April the 12th or the 19th.
Yep. So, one of those.
You
Stay
know,
tuned.
There's a way that you could find out when that's going to be, though.
How would that be?
Well, although this right here,
Because I don't even know when it's going to be.
this still right here is showing you that These are Ham College areas here, but if you insert the word Amateur Logic where it says Ham College, but usually we'll have it on both of them. Facebook.com/group/Ham College or /AmateurLogic.
Yeah, you can follow us at Ham College or Amateur Logic on Twitter, or both, actually.
Or X.
That too.
Not Y, though.
No.
Or groups.io/G/AmateurLogic. You can subscribe there, and you'll get a message, email coming in whenever there's an announcement about an episode has been posted or a live stream is going to happen. Or one of the monthly nets is going on.
If you're not into social media, that's your best bet to get notified. We don't send out a lot of stuff on there.
Yeah.
Occasionally something to come through, but for the most part, it's mainly just for announcements.
Yep. And if you need show notes,
we got them. AmateurLogic.TV /wiki. You can find the Amateur Logic and Ham College show notes down there. So most things we talk about, if I'm provided with links, they end up in the show notes, and you can use those to look for products, information, or whatever that we discussed.
Yep. 7-3, everyone.
Yep. 7-3.
Happy Easter.
Happy Easter. We'll see you next time.